Greetings, everyone. This is a lecture from the applications of maths, but I'm making them a little bit later. I mean, I have done a couple of videos before, and now I'm turning to these, understanding that the students need these basics. I'll be trying to do this lecture in English. The reason being that some of you have requested me to change the languages a little bit so that they could find the right comfort spot to understand the best. Let me introduce some of the tools today that we'll be using throughout those videos. I mean, what I recommend is that you watch this video and then those videos. And I hope I've uploaded it the same way. So, among the tools, the first ones are fractions and percentages. And why have I put them in a single unit or a block? The reason is that I believe that both of them are the same thing. We will see why I'm saying that. The second is the unitary method, or most of us call it the ratio method. And this is quite useful because this gives us a linear thinking path, a really lucid thinking path. The reason is that you just put a quantity here, a quantity here, and then you put the analogous quantities here and here. And that's mainly how the problem will be solved. We will see how that works. Proportions is a bit like ratios, but the thing in proportions is that when one quantity is increasing, the other quantity will also increase if it is related in the same manner. This is much like those topics of similarity and congruency. Well, similarity actually, in which you have a scaled up picture or something, or scaled down picture of something. And then I have put this other one where I have, uh, and then I have number four, which is unitary method and rate again. Now, rate can be derived from the unitary method, or rate has its own identity as well. So we'll be seeing. Let me know down in the comments if you are comfortable with this mode of language. Alright, let's begin with percentages. And yes, I have used a different page for this. Percentages and fractions. I want you to imagine a land. The land might not be uniform in any way, but you could estimate that what percentage or what fraction of it are we talking about. What do I mean by that? Let's imagine a person, Mr. Ali, who has two other brothers. So there are three brothers, Mr. Ali, Mr. M, and Mr. L. Now, one day, Mr. Ali decides that it's time that we had our own share of land that our father left us. So he says that I'm taking one third of the land. And the other brothers are like, whoa, 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 hold on. We don't understand what this one third means. I mean, what do you mean by that? So Ali is really good in mathematics. He says that, do you guys understand the figure of 100? And they said, okay, yeah, we do. Well, he says that when I said one third, I meant that this was one single land. And one single land means that I could break that up into smaller decimals or smaller fractions. But the brothers are not so comfortable with that. So Ali comes up with this new method. He says that, what have I told you that this whole land was like 100% of the property? They're like, 100%? What is this word percent? He says that don't worry about that. That's just a fancy word for saying 100. So you're saying, okay, you're being redundant. You're saying 100 and then you're saying percent. Anyway, what do you mean by 100? He says that try to understand it as if the whole land was worth 100 pieces and that I am taking only one third of it. They're saying, we don't understand. He says that imagine the land had 100 pieces and I just took one third of them. And taking one third of them is just like multiplying that with 1 over 3. What you get is 33%. And they're like, huh, 100 pieces of land and you get 33. We get it now. Yeah, that makes much more sense. And he's saying, like, that makes much more sense. Yeah. You understand the value of 1. We don't like fractions. So we do understand that, okay, you have 100 pieces and that you have taken 33 of them. Yeah, we were totally comfortable with that. Now, Mr. M is actually comfortable with that. Mr. L says, whoa, hold on. Why don't we break this down into a million? They're like, what's wrong with you? What value does a million have? And he says that our land is worth 1,000,000 rupees. And they're like, okay, so 100 was arbitrary. 100 didn't have a special value, but we started understanding it very well. And now he's thinking that why don't I devise a number that actually means something? The land is worth 1 million. So he says that, okay, Ali, you want to take the land right now? Fine, take it. We don't care. Here's 1 over 3 multiplied by 1 million. And they're like, we're understanding the values of fractions. I had to multiply 1 over 3 with 100 to get a percentage. And now that we have 1 million, we're multiplying the same 1 over 3. So now Mr. M is like, hold on for a second. I understood the 33% and I want that as a general rule. For example, maybe someday I'll have this crooked land and I would want 45% of it. But I don't know what fraction that is. And we're like, don't worry, don't worry. Fractions and percentages are just the same thing. You just divide the percentage by 100. And he's like, that's all I need to do? And they're like, yeah, sort of. This was a 33.3333333 recurring decimal, but yeah, that's pretty much what you have to do. So now I get it. But they're like, okay, M is stupid. We gotta explain this to him in another way. So they say, no, we're gonna explain this to you by ratios. And he's like, ratios? You were talking about percentages just then. What about ratios now? Guys, I know that I'm changing my accent over and over again, and this time this probably sounds really cringy, but bear with me. So they're like, uh, you remember about the 100%, right? And I'm like, yeah, 100%, big deal. 33%, yeah, I get it. 100 pieces, and I get 33. Oh, no, Ali gets 33. Big deal. And they're like, okay, listen to us. Yes, you can think of it as 100% and 33%. But remember when I said 1 over 3? You don't really need to think about it as 1/3. And M is all confused again. And he's saying, what do you mean? They say that try to understand that this denominator is a really good signal. And he says, how? They say that consider this as a total. And he's like, come on. Sometimes you say 1 million, sometimes you 100%, sometimes you say 1. Here's this new cool trick. If you have 3 pieces of land and I, Ali, get 1, for every 3 pieces of land, I, Ali, can get 1, then imagine that if I had 1 million dollars, how much would I get then? He's like, how do we do that? He says, just cross multiply that. He's like, okay, I don't really understand the logic of it, but does this work? And they're like, just think about it. The x is going to multiply with the 3, so that's going to become a 3x. And the 1 is going to be multiplied with the million, so that's going to be 1 million. And when you divide it, that's just going to be 1 over 3 into 1 million. That's what we did over there, with here, see? That's what we did. You just use ratios. And he says, I'm not cool with this ratios thing. They're like, okay, try to understand it this way. We have a pie, okay? We have 1 pie, and I break it down into 3 parts. That's like grade 4 stuff. And he's like, okay, and then Ali says that I get this one, and he's like, oh, whatever. And he's like, oh, now imagine that I have 3 pies. It's like, okay, I don't understand where this pie thing is going. It's like, you'll understand it soon. Just wait. So when we had 1 pie, you had 3 pieces. And you're like, yeah. So so in one pie, so try to understand the beauty. When we had 1 pie, and now I'm writing down pie over here, we had 3 pieces. And it's like, okay, now that we have 3 pies, it's like you got 9. And they're like, yeah, you're right, but we want this consistent method. So you have X. And he's like, no, I understand that they're 9. And they say, you know about proportions. And he's like, no, I just multiplied it by 3 because now I have like, you got this 3. I counted them. They're like, wait. Yes, I know you counted, but now you do cross multiplication and you get x equals to 9. The both of these threes multiply. And he's like, okay, I'm getting a hang of this. And he's like, can you guess how many? And Ali is like, can you guess how many pieces do I get? And he says, well, let me think. If I had one pie and you got one piece, and now that I have three pies, you get three piece. And they're like, yeah, you know proportions, but try to do that with the unitary method. And he's like, okay, x and multiply x. Okay, I get x equals 3. Fine. And then they're like, okay, now think about how many pieces do you get? And he goes, well, if you get one piece, then maybe L and I get two pieces. And they're like, correct. Two pieces per pie. Then how many pieces for 3 pi? Yeah. And they're like, yeah, you understand really good. And you can cross multiply it. 2 3s are 6, and x times 1 is x. You get 6 pieces. And it's like, I don't understand how I do this by property. And they're like, okay, you are just getting a hang of this thing. Okay. Now come back to percentages. For example, I said that you get 33% of the land. What if someone asks, gives this into a fraction? I'll just divide it by 100. We know you divided by 100, but when you divide any number by 100, what do? He says, yeah, I got that from elementary maths. I go 2 decimal places back here, 0.33. Yes, exactly. That's what you do. So from now on, how about whenever we give you a percentage, for example, even 125%, and he says, 125%, how do I get 125%? And you're like, what if you invested your land and got more? And then he's like, okay, get the point. What do I do with this 125%? Well, 125% is a percent. It's multiplied by something. What is this in a number form, in the fraction form? And he's like, I divided by 100. And they're like, that's exactly what you do. You divide by 100%. And he's like, okay, whatever. And what do I get? 1.25. And yes, that is a profit. For example, you had invested everything you had into something and you got 1.25 times what you had. And he's like, oh, now I'm getting things. And they're like, thank God you're getting things. Okay, finally, because you have a very rough idea, what you can do now is solve this problem for us. He's like, okay, you go to a supermarket and have 5,000 rupees. You use 2/5 of the money. I have a problem with these fractions. And they're like, just relax. 2/5 of the money, you can turn that into percentage. Or maybe you can just multiply it with the total. It's like, yeah, I remember. And then, okay, what does the question say? Okay, to get veggies, 5% to get treats. Okay, 5% of 5,000. Okay, to get treats, you need to use half of the rest to purchase eggs from 300 per dozen. What does that mean? They're like, well, we didn't actually explain to you about the rates. And he's like, rates? And like, okay, start solving this and we'll help you. He's like, okay, amount spent on veggies, I can understand. Okay, amount spent on veggies. Okay, so I know it was 2 over 5. I understand fractions. 2 over 5 is like, uh okay, if I had 5 in total, if I had, this was the whole of my existence was $5, then I would use only $2. Did I make the right the right ratio? And they're like, fabulous. And how much do you have? He said, I have 5,000. Great. And then he says that, okay, I have a hang of this. 5,000 gets multiplied by 2, and 5,000 times 2 is just 10,000, right? And we're like, wow, yes, you're right. And then this 5 is gonna get multiplied with this x, so 5x equals to 10,000. Brilliant. Yeah. That's perfect. So x is equals to 10,000 by 5, which is 2,000. Perfect. So you understand fractions now. So in fractions, you can treat the denominator as the total and the numerator as the part that you're allowed with. So 2 by 5 just means that if you had 5 pieces, you could acquire 2 right now. It's like, yeah, now it makes sense. Amount spent on treats, 5%. And he's like, Yeah, I remember percentages if I had 100, but I don't have 100 right now. See, I had 5,000, and of course, I have used 2,000, so I have 3,000 left. I know that, but 5% of what? And we are like, okay, 5% of the total. It's like, okay, 5% of the total. And how did I do that? I don't have 100, 5%. And he just remembers that 5% is the same in fractional form as 5 upon 100. And he remembers that this percentage is just a number that was so very convenient because we could understand the value of 100 and understand that if we had 100 parts and we could acquire 5 parts, then that meant something in fractions as well. So when he has 5%, he knows that I just have to go back one place value, another place value. So 0.05. So 0.05 is the same as 5%, you're saying? And we say yes. It's like, oh, okay. So 0.05 is a fraction. It doesn't seem like a fraction, and we're like, okay, when you divide 1 by 100 and you get 0.01, that is a fraction, but in decimal form. So it is another form of that same fraction. And I'm like, okay, so I'm supposed to multiply this 0.05 into, I don't know, 5,000? And we say yes, but if you divide 5 by 100 and multiply it by 5,000, you're gonna get the same result. He's like, yeah, yeah, yeah. Makes perfect sense. I get 250, right? And we're like, yes, you get 250 rupees. Now in part C, I use the fact that I have 5,000. I use 2,000 and then I use 250 again. I use this fact and it's like, yeah, you have 2,750. I'm like, wow, I understand this simple mathematics. And they're like, no, you still don't. Think about eggs. And he's like, eggs. There was something regarding rates over here. Think about rates. What rates are, you ask anyone that, for example, I want to trade, and you are back in the medieval days, right? So you ask that if I have 1 unit, and this has to be 1 unit of quantity A. So if you have 1 unit of quantity A and you want to trade it for B, how many B do you get? And you're like, okay, so I'm supposed to know that if I have, say, 1 toothbrush and I sell it, how much money do I get? Do I need to know that? Like, yeah, something like that. You're on the right track. Basically, what you do is you divide one item by the other. It's like, what do you mean? For example, you had $250 for 10 toothbrushes. Then you know that each toothbrush costs 25. See, this denominator has a 1, and this 1 means that you can trade this one toothbrush for these $25. So when you write a rate, you are basically writing that in a trade for one of something, what do I get in return? And we do not write fractions like that, right? For example, 25 over 1, that's just silly. We just write $25 per toothbrush. And that makes much more sense, right? So when I'm writing 300 rupees for 1 dozen, what do you mean? Well, if I bought 1 dozen, I would give them 300. Or if I sell them a dozen, I get 300, right? And they're like, perfect. But son, you need to think about this in a different way. How much for a single egg? He's like, single egg? Who buys a single egg? And Ali says, I want to buy a single egg. And I don't know how far you have followed me through this story, but bear with me. Okay, so 300, we can develop a new rate using this. 300 means 12 eggs. You see what I did? I am changing this rate. I'm saying that if I give 300 for 12 eggs, how many do I give for a single egg? Cross multiply that as well. So we are doing this by ratio as well. 12x equals 300. That means that x equals 300 by 12. Or like bingo. So you get a single egg for 25 rupees. Okay. and the remaining money that you have is the remaining money being 2750. You use half of that. So in part D, you use 2750, you divided that by 2, and you get 1375. Now you get to ask yourself one question. If for a single egg, or for 12 eggs, yes, you already know the rate for 12 eggs. For 12 eggs, I get 300 rupees. So if I had 1375 with me, how many eggs do I get? Just multiply that. You get 12 times 1375 divided by 300. And the answer is you get 55 eggs. And see, if you went by those dozens, you couldn't actually get these. For example, you had to go with those dozens. Then what would you do? Well, you know that you need to divide this by 12 actually. And then find the remainder. 48, because in a dozen, you can only take 48. What about the rest? The 7 of the eggs you can either put back, or you can negotiate that I want these 7 of them back. But let's say that you couldn't get these 7 eggs, so you return them and you get only 48. How rates work is that you write down that for each dozen you get 300, right? 300 per dozen. And how many dozens are 48 eggs? Well, 48 divided by 12 is like 4, I guess. Yeah, 4. Yeah, 4 dozen. So 300 multiplied by 4 dozen just gives you money. The units satisfy themselves as well. The units are of rupees now. You get 1200. And remember, you were allowed to use 1375s. So you have 175 left. There's an extra that nobody's going to use right now. Now, there was another part of this question that I'm going to skip. So here's what we're going to do. This 175 is going to be the remainder. Nobody uses it. The rest of the money is used. Now, making this video in English was a little difficult, but it was actually better for me because I got to express myself in a different way. This video is probably very, very long, and some way down the line, I forgot that example about Ali, Mr. M, and Mr. L, but we still made the best of it. I hope you guys are continuing your practice and you understand. Okay. So I probably upload this video before any other. So yeah, you guys are not practicing. You will be practicing in the following coming videos. So I'll be doing profit loss, I'll be doing hire purchase, I'll be doing discount interest, and I'll be doing commission and some other topics, and maybe. So thank you for watching.